In this video we will be solving first order differential equations. This time we will solve exact equations. So what is an exact equation? There are two conditions. Number one, we should be able to write an equation in this form, and it should obey the condition that partial m by partial y is equal to partial n divided by partial x. We will take an example to illustrate our concept of an exact equation. This is a given equation. Now we can rewrite this equation as this equation that meets this requirement, and second requirement is that we should be able to find partial n by partial y as equal to partial n by partial x, which is indeed the case in this given differential equation, because partial n by partial y comes out to be 2x, and also partial n by partial x comes out to be 2x. So both are equal. This condition is then satisfied, and therefore this equation is an exact differential equation. The solution of an exact differential equation is given by uxy is equal to c, which equivalently may be written as its differential form du is equal to this. Let's name this as equation 3. Equations 2 and 3 are 0 each. Thus we may equate them and get, this is what we can get, and we call it equation 4. Similarly, we can also get by this comparison partial u over partial y is equal to x squared plus 3y squared. Let's call this equation as number 5. Integrating equation 4 with respect to x, we get u is equal to x squared plus a function phi of y. Equation number 6. In the integration of a partial derivative with respect to, say, x, the constant of integration is taken as a function of the other variable, that is y here. This could have been a constant, but for a partial derivative of u with respect to x, this is still a constant because it becomes 0 then. Now over this equation with respect to y, we will get partial y over partial u over partial y is equal to phi dash y. This is equation number 7. But partial u over partial y is equal to x squared plus 3y squared is equal to n as per the given equation. Therefore, x squared plus 3y squared is equal to phi dash y. Therefore, we repeat it here. Phi dash y is equal to x squared plus 3y squared. On integration, equation 9 gives phi of y is equal to x squared y plus y cubed. Substituting the value of phi y in equation 6, we get u value as this. Thus the solution u is equal to c becomes y into x squared plus y squared is equal to c. Now we will take up the next example, 22. Example 22. Solve this equation. Solution. The given equation is an exact equation because it can be written as this, and also this equation obeys the requirement that partial m by partial y is equal to partial n by partial x. So now it is confirmed that equation 1 is a partial differential equation. The solution of an exact differential equation is given by this. which equivalently may be written in its differential form as du equal to partial u by partial x into dx plus partial u by partial y into dy is equal to 0. Equations 1 and 2 are 0 each. Thus we may equate them and get partial u over partial x is equal to 3x square into y, and partial u by partial y is equal to x cube plus 3y square. Integrating equation 3 with respect to x, we get u is equal to x cube into y plus 5y. In the integration of a partial derivative with respect to x, the constant of integration is taken as a function of the other variable, that is y, as taken here. Our differentiating equation 5 with respect to y, we get partial u by partial y is equal to x cube plus 5 dash y. But partial u by partial y is equal to x cube plus 3y square is equal to n as per the given equation. Therefore, we get 5 dash y is equal to 3y square. On integration with respect to y, equation 8 becomes 5y is equal to y cube. Substituting the value of 5y in equation 6, we get u is equal to this. Thus the solution is, as mentioned previously, u is equal to constant, and therefore the solution becomes this. Checking your solution. In example 20, we solved this equation. Our solution was this. Use this solution to obtain du. We note that from the solution we get partial u over partial x is 2xy. This is from here. We take the partial of u, because this is u. Partial of u over partial of x is equal to xy. And from the same solution we also get partial of u over partial of y is this. Thus du becomes what? This is du. We substitute this and this to obtain this value of du. And on the right hand side, differentiating c and putting it in du, this is 0. This is the same as the given equation, thus our solution stands verified. Thank you.